This is modular equal sum. And for the rules, we have normal Sudoku rules. So every row, every column, and then every 3 by 3 box must contain all the digits from 1 to 9. Then we have the lines, which are which combines various line constraints all in one. So these are modular, so it's modular lines. Any sequence of 3 successive cells on the line must contain a digit from 147, another one from 258, and the third one from 369. And digit may repeat on the line if allowed for another rule. So for instance, these two might be the same digit. But lines not only are modular lines, but there are also Dutch whisper lines, so all the lines, and so the difference between every adjacent digit along the line must be at least 4. So it could be 5 or 9. It's like German whisper line, but instead of using a difference of 5, it's 4. So a 5 could go on the line with 1 and a 9, for instance. And so these are modular lines, these are Dutch whisper line, and these are also equal sum lines. So well, appropriate. This is not an equal sum because it's all in the same box. But as an equal sum, so the sum of these 3 digits, every line segment which is on the box, as an equal sum. So these 3 digits are the same sum of the sum of these three. So the sum of these 2 is the same as the sum of these 3, and so on. So except for these 2 lines, so these are equal sum. So that's for the rules. And we might start here. So it's indeed like a narrow sum. So there's one cell which equals 2 cells. And this can't be 1, 2, and 3 because of the Dutch whisper line. So the minimum it could be is 1, 5, because there must be a difference of at least 4. So the minimum is 1, 5, which is equal to 6. So it's 6, 7, 8, 9, and the same here. 6, 7, 8, 9. But if it were 1, 5 would be okay, and it would have to be 1, 5, 6 because of the Dutch whisper line. So it would be the low digit. And if it were 1, 6, and 7, there is a problem with the modular line because 1 and 7 are from the same strata. So this can't work. And of course 2, 5, there's no enough room for this. And 4, 3, 6, no either, because they are also from the same strata. So there is no 9 in there. And indeed, any row of 3 digits, a modular digit, is a multiple of 3. This is another way to see it. Forget about the Dutch whisper rule. So if it were 1, 2, and 3, which is the minimum, and then you could jump to, let's say, replace 1 with 4, so this add 3, or 2 with 5, this add 3, or 2 with 8, this add 6, or 3 with 6 or 9, this add 3 or 6 respectively. So it's always an increment of 3, starting with 3. So the total sum of these 3 is a multiple of 3. So because this equals the sum of these, so it's indeed a multiple of 6. And because it must be divided by 2. And so a multiple of 6, we know this is at least 6. And 8 plus 8 is not a multiple of 6. Another way to see it is 8 goes either 1, 2, so we are missing a 3, 6, 9, or 2, 7. We are also missing a 3, 6, 9, or 8 could be 3, 5. So it would be missing a digit from 1, 4, 7. So this is not 8, so it's 6, 7 pair. I will highlight this 6, 3, 6, 7 in modularity in blue. So 6 could be 1, 5. It can't be 2, 4 because this is too small range between 2 and 4 for the Dutch whisper rule, and 6 must be here. It can't be 6, 9, 6, 5. So this is the only option for 6, and for 9 it could be 1, 8. So this could be 8, or it could be 2 and 7. No, not 7 here because with 9 can't. So 7 and 9 can't go next to each other because of the Dutch whisperer line. So 2 and 7. And indeed, it can't be 3, 6 because it would be all from the same modularity. This doesn't work. And 9, 4, 5 doesn't work either. 4 and 5 are 2s. There's no difference of 4. So that's all for this kind of line. So indeed, you can do the same here, and then with 4, 7, or 8. And so 1 will be, because these are different, and these also are different, there is one which is 6, so there is always a 5 in there. So there's 1, 2, there's always a 5. And 1, 2, so 2 goes with 7, because of the 6. The other one can't be 2, 5. So there's a missing 1, 4, 7 in there. 2, 8, sorry. This is indeed 10, so there's no 8 here. So it's indeed a 5, 8 pair. Because this is how it works together. Now, this run of 3 digits must contain one of each modularity. So here we have for 1, 4, 7, we have 1, 2, and 7 here. So the 4 must go on this line. And we have a 2, from 4258 we have the 2 and the 5 on these, so must also contain 8. So the minimum here is 12 plus 3 could be 3, 6 or 9 for the yellows, the 369 modularity, but there is only one here, so the other two goes here. So now these are 369, so 12 plus 3 is 15, so this is 15, 18 or 21. So if it were, I should have 4 and 8 here, so 4, 8 and 3, this is 15, 4, 8 and 6, this is 18, and 4, 8 and 9, this is 21. But indeed I think 21 there are not that many options which work. 4, 8 and 9, because of the 8 and 9 can't go next to each other, so they would have to go here with the 4 here. In case of so this cannot be 8 nor 9. Let's see, if it were 9 it would be 4, 8, so there would be a 9, 8, so this is not a 9. If it were 8, it were 6, it would be 4, 8, so this doesn't work either. And if it were 3, this would be 4, so 3, 4, this is also not working as a German Dutch whisper line. So here we have a 4 or 8, so there's a 4, 8 here, and so I'm just thinking if this could be 3, so it would be 3, 4, 8, yes, this way. If it could be 9, 9, 8, 4, yes, 6, so this cannot be a 6, because 6 is 2, there's no difference with 4, 8, so there's no 6 here, so 6 goes here, so this is either 3, 4 and 8, which is 15, or 9, 4 and 8, which is 21. But for 21, what other option do we have? Using different modularities, there are not so many. So let's see with 6. Well, also remember that there is a German whisper rule, so it could be next to 1 or 2. So at most this is 8, and then if it were 2, maximum would be 7, because we need from 1 for 7, so 6, 6 to 7 is the maximum with a 6. Can't be 2, 6 of course, not 2, 5 because they are missing 2, 4. Or if it was 6, 1, this could be at most 8. So with a 6, we have at most 6 and 9. So and this is 15. This is the maximum we may have if we are using a 6. So it would include also a 9. So this would be 9, 4, 8. So these are the same modularity. These are the same. Sorry, these. And these are the same. So if it were 21, so it would have to include the 9. So it doesn't go there. Let's say it would be there. This would be a 4 because we can't have 9, 8. So the 8 would go there, and then this is the same modularity, and we would have 9, 8 next to each other, which so there's a difference of 1 and not 4 at least. So it doesn't work, and if the 9 were here, this would be 4 and 8, and this would be the 9, so there would be a 8, 9 here or here. So there's no 9 in there, and the sum is 15. So it's a 6, 9 pair here. So this is 15. There's a 3 here, so this can't be 4. This is the 8. So this is 3 and 4. So this modularity here, we know it is 258. So I will use yellow for 258. So this is 2 or 5. So we need what, to 15. So if it were 5, then these would sum to well, remember the Dutch whisper line, so this is at least well, at least 3 plus 4 is at least 7, so it's 7 and 8, and we know it can't contain a 9. We've already viewed this. Oh well, it could be 9. Let's check this. So here the minimum is 2 and 7. So 2 and 7, this is 9. So for 15, this would be 6. Maximum is 6. 2 and 7, this would be 6. 7 to 6, 8. Well, it can't be an 8, we know from here, and we know from modularity, so it's a 7 or 9. And if this is 7, this is 2. So 7, this must be a 2 with a 6. If it were 9, this could be 2 and 5, because 9, 5 works. So 9, 5, so this would be a 1. 9, 5, 1, yes, this works. 9, 2, which is 11, so it would be a 4, 9, 2, 4. 2 and 4 won't work, so it's at 7, 7, 2, 6, or 9, 9, 5, 1, 9, 2, which is 11, 9 to 4 won't work. And it looks like, oh no, this is not exactly the same here. So 6 would require 5, or a 2 or a 5 there, and this would be 1, 4, 7, so 6 would be a 1. If it was 6 here, and if it were 1, it would be a, so 1, 9, so this would be a 3, 6, 9. 1, this could be a 6 or a 9. So yeah, whichever the case, there is a 1 in there, I guess. And this is a 1, so this must be a 6 because this is a 9. It's a 6, so it's a 1 because it can't be a 2. So there's always a 1 in there. Don't know if it's that useful. And so this is 2, 5, 8. This also. And one can go with 5 or 8. I'll go with 2. 9 would go with 2 or 5, and 6 would go with 2. So I'm wondering if this can be 3, 6, the 3, 6, 9 color. So this would be a 3 and 15. So this added 12. So this would be 3, this would be 3, and in order to have 12 we will need 5, 7, or 4, 8. Oh, this could not be, this would be a 3, so this could not be 4, 8 and 4, because 3, 4 here doesn't work. So if it were a 3, this would be 5 or 7, so 5, 8, 1, 8, 4, which doesn't work. So this would be a 7, sorry. So 3 will be 7, 3 is 4, 9. No, if the 3 is here, no, well, if this is not the 3, this would be 4. Oh, this, so if it were, so if these were the blue 369, this would be 4. So we would have to place 9 here. I think this is the same as this. Place a 9, 7 or 9, so this can't be 8. So 3 would place a 7, can't put it at 8 for various reasons. And 4 would place 9. So this is the same as here. So 7, 9, we can't place 8 here. So it's a 2, 5. I'm just wondering if I could place a 3 here. 3, no, this doesn't work. So this is not the 369 color, but the 147. So I will turn this into red and this one into blue. So this is a 3. This is a 6. This is 9. So can't place. So 6, 9. 6 gives us 9, 6. So this is not a 3 but a 4. This is not. This is 7. So 6s and 7. This is 13. So we need 2 to get 15. Yes, 12 and 3 is 15. So this is not the 6. 6 can't go with a 9, is it? It's a 5 or 6. Yes, it's 1 or 2, so this is 1. And 5 or 8 is okay. 9. So 15 minus 9. This is so this is 6. This is up to 6. It could be 5. 1, 1, 2, 4. 2, 4 doesn't work, so this is 5. 1. So now this is 3 is to 6. So 6 or 9. So this sum to 14. So it's 9, 5 or 6, 8. 6, 8 doesn't work. So this is this, but we already know this is a 5, and this is a 1 for various reasons. This is a 5, this is 7, 2, not red, but so 7 is red, and 2 is yellow. No. Here we have also the same kind of thing we get here. So 1 cell equals 2. So this is 3, 6, 1, 9. It can't be 6, it can't be 3 because 1, 2, 3 is doesn't work with the Dutch whisper line, so it's a 9. And it's either 2, 7, like 2, 7, like this, or it could be 1, 8. Of course, not 3, 6, nor 4, 5. Here we have 3 cells which are from different modularities, so it's a multiple of 3. So the sum is a multiple of 3, and there is a so these two must be a multiple of 3, so they can't be 3, 6 because, well, we need 3, 6, and 9 every modularity here. So this is multiple of 3, this is a multiple of 3, can't contain 3, 6, so it must contain a digit from 147 and another digit from 258. The reason is that well, if you add 2 and 5, this is 7, so not a multiple of 3. 2 and 8, this is 10, and 5 and 8, this is 13. So. And the same here for, there's probably a mathematical relation about this, but I know that if I need a multiple of 3 in 2 cells, they are either 3, 6, which can't work here, or 3, 6, 9, or one of each modularity. So there is a yellow here, it doesn't go here, but here. So it's 5 or 8, and there is red here, it's 1 or 4. So this is blue, this is red, this is yellow. So this is 3, 1, 6. No, 1 or 4, so could be 1, 5. 1, 5 is 6. 1 would be 3, and 1, 2. This doesn't work for the Dutch whisper line, so it can't be 1, 5. So if it were 5, this must be a 1, so this is 8. And this could be a 4 with a Dutch whisper line. 4, 8 is 12, 1, 8 is 9. 9 would be either 3, so the 8, this can't be 6, this can't be 6, this must be 3, because of the Dutch whisper. So 8, 8, 1 would be 9, so this would be 6, 6, this would be no 1, so 4 or 7, or 7 and or 7 and no, or 4, this would be not 4, 5, so 7, 2, yes, this would work, 7, 2, if it were 1, 7, 2, so 1, 8, 3, 7, 2, this work on Dutch whisper. Or it would be 4, 8, so 12, so this is 3, so this could be, oh no, let me see, if it were 9, so 1, 8, this indeed is at least, this must be a 7, there's no other way, can't be 1, no 4 next to the 3, so this is 7. So this is 10 at least, so this can't be 9, this is a 4, so this is 12, so this is indeed 7 and 2. And here we know it's 8 and 1. So no, probably Sudoku would help. So I see 9, 9, so 9 goes here. 6, 6, there's a 6 over here. 2 and 2, so there's a 2 here. 7 here. So this is for this count, so maybe we should look here for this, maybe here, because it is most, so it can be 1, it can be 2, 3, not 4, not 5, not 6, not 7, not 8, not 9, so it's a 2, 3 pair. So these are 1, 2, 3, 4, 5, 6, 7, and 8. 7 and 8. So far not useful. And here we have so 1, 2, 3. There is a 3 in there. Yes, because of this 3, there is a 2 up there. Continue 3, 7, 8. So this is not 7, 8. This is 3 or 4. I don't know if it's useful. And here we have, so we have 2, 3, 4, 5, 6, 7, and 8, and 9. So there's no single 8 here. There's no 2. So check again. 1, 2, 3, 4, 5, 6, 7, 8, and 2. This is a 4, like a single 4. So this is a 3. There is no 4, 3. we have a 2, 7, 8, and this is known because of the 3 pairs, so this is 1, 2, 3, 4, 5, and 6. So this is 1, and that's it. Looks like there are many 9s. So the 9 goes here, and continuing goes on the line here, and the 9 goes here, and the 1 also. 1, 9, 1, 9. So this is a 1, 9 pair. 5. So this is the 5. 6 goes here, and here. 1, 9. So there's a 6 here. So what are we missing? What else are we missing here? This is a pair, a 6 and 1, 6 pair. Because we have everything, so 1, 6. I should have noticed this before. So the 1 goes, so this is 9, 1. And the 9 goes here. We have all the 9, yes. So for the 1s, there's a 1 here. So let's check here. What are we missing? 1, 7. So 7 doesn't go here, but 2 and 5 and 3. So this is not 2, this is not 7, 3 or 5, 3 or 7. So this is 4 or 5. There's no 2 here. 5. So this is the yellow one. So we need what do we need here? Blue from 3 or 6. So if it were 3, 6, it would go here. And we need yellow. So it can't be 5, so it's 2 or 8. So it could be 2. And so this could be 2 with 3 or 6. And this could be 8 because here 8 with 2 with 3 or 6, but I remember the Dutch whisper rule, so it is not 3. 8 with 2 with a 6. That's okay for a Dutch whisper 9. Or 8 with 3. Can be 6 or 9, but we know that. So what are we missing here? 2, 5 and 6. This is not the 6, so it goes the 6. So this is 8 and 3. So 5. This is 2 and 5. This is 3, 7 and 2. 7, 4, 5 and 6, and this will be a 4, this is a 4, so this is not the 8, nor the 7, so this is the 4. So here we're missing a 7 and 8. So here this is a 2 or a 3, the other one, and here we have a 7, 8 pair. Can't decide this yet, so this is 2, 3, 6, 7, 8 and 9. I'm missing something before. So this is not 2 or 6. 3 or 4. Yeah, we're missing 8 and 3. So this is not 3. Here we have 1, 4 and 5. So this is not 1, 5. 4 goes here. not if I for speed solving, not puzzle with other combination, I would use this to put the two here. Otherwise, it would make it a deadly pattern, but I won't do it. So no, here we have 8 and 7. Well, I don't know the other yet. 7, 8. 7, 8, 7, 8. Well, this is indeed a 2. That's right, but I could prove it. And 2. So this 7, 8 loop here, but 5, 6. This is probably for the same reason, probably a 1. We will see. And so we have 5, 6, 7, 8. So we are missing only 2 here, which are 1, which are 2. So this is the 2. And a 4. Yes. So this is 4. This is 4. 6. So here this must be yellow for the line. And this also. So it's not 7 but 8. 7. So now we know these are 7. These are 8. So 12, 8 is 5. 1. 6 and 5. 6. And 1, 5. And this is a 3. 6 goes here. And the last one is a 1. So that's it.